Welcome back to the Introduction to Particle Systems. In this video, we are going to walk you through the creation of your very first particle effect, which you actually saw in the last video. It was that simple spark effect that we had coming out of the mouth of this dragon that you see here on the screen. Now, as we progress through the creation of this effect, you're going to learn a lot of things about particle systems. You'll learn about emitters and how they're placed into a particle system. You'll learn about modules and how they're added into the individual emitters to create each of the pieces of the effect that you're going for. We're going to give you a really basic tour of the Cascade user interface to get you started, and Cascade is, of course, the editor you're going to use to create particle systems in Unreal. Then after we have created our effect, from that point, we're going to give you a more thorough walkthrough of the Cascade interface. Now, you might be wondering, why don't you just give me the hardcore tour to begin with? Because several parts of Cascade are easiest to show off once you have something to show. So we're going to give you kind of a monkey see, monkey do approach to creating a simple effect. And then when we're done, we'll show you everything that the editor can do.
Okay, sounds good. So let's go ahead and get started. Now, creating a particle system is very much, like I said in the last video, creating a new material, where you will begin on the generic browser by right-clicking, coming down, and creating a new particle system. Now, of course, you're going to fill out the standard information required, such as what package are you going to be storing this particle system in?
I needed to capitalize that. It just drives me crazy.
And then what group?
And this is actually going to be Zach's particles, just so we know. Our group is going to be P Systems.
Okay.
You can call it whatever you like, though. And I'm going to name this effect part_simple sparks. Now, this is just me. I like doing the part_ prefix because it makes it easier to search later, but that's just a naming convention I use on my end. Let's go ahead and click OK. And after it takes a second to load, what happens is the Cascade editor appears.
That's right.
Again, Cascade is your particle creation tool for Unreal Ed. Now, before we do anything, let's give you the really quick dime tour so you know at least what to click on as we create this effect. We have a menu bar across the top. We have a toolbar. Something kind of interesting about the toolbar is that mine will seem to end probably before yours does because we're recording this at a lower resolution than you're probably viewing. And so I think really all you're missing here would be a couple of buttons and a drop-down.
Which we'll talk about.
Yeah, we'll go over this so you know what they do. In the upper left-hand quadrant of our main user interface window, we have the preview window, which is where you're going to see your effect while you work on it in real time. We have the emitter list here on the right. This will show you all of the emitters as you create them and all of the modules that plug into each one of those emitters. In the lower left-hand corner, we have the properties window. This is where you're going to see and adjust all of your properties. It's very much like the properties windows available all across Unreal Ed. And then over on the right-hand side, we have the curve editor, which is exactly like the curve editor that's available inside of Matinee. It's just a way for you to change any sort of property that is mapped over time. Okay, now with that, time to go ahead and start creating our effect. The very first thing we need to do is add our first emitter. So we come over to the emitter list, this big black blank area over here in our window, right-click and choose New Particle Sprite Emitter. Boom, and we immediately get a sprite emitter. Now, what is a sprite emitter? It is an emitter that will create sprite-based particles, which are particles that have a small piece of square geometry attached to each point, and that piece of geometry will always face the camera. There are several types of emitters that you can create inside of Unreal. Now, to give you a quick a demonstration of the ones that are available to you, I'm going to right-click on this emitter and come down to Type Data. These are a list of modules that you can add to your emitter to change the type of emitter you have. So if you want a beam emitter to create things like laser beams or lightning bolts, you can add a beam data module. If you want a mesh emitter, which will emit static meshes at the location of each particle, you can use a mesh data. We have a couple of different types of fluid emitters if you want to create a fluid effect. And then we have trail data if you want a trail emitter. And essentially what a trail emitter is a special type of emitter in which you will animate the emitter actor in your level and it'll leave a trail behind it. Now, in this video series, we are only going to be working with the basic sprite emitter, but I did want you to be aware of the other types as well. Okay, so jumping in and taking a look at what's going on here inside of our preview window, you'll notice we do have some particles appearing. They've got a funny little texture on them. Just for a second, I want to show you something. We've been talking about sprites and how they are just like a piece of geometry, a square piece of geometry that is always facing the camera. If I switch this over to wireframe mode, which I can do by clicking on the toggle wireframe button up here in the toolbar, you can actually see each one of these sprites. So I just wanted to show that off to you before we go too much further. Okay, for the creation of our effect, the first thing I want to do is name our emitter. Currently it has the name particle emitter, which I'm just not buying. That's not very descriptive. So the first thing we'll do is change this. We can do this by clicking on the emitter itself and coming down to the properties window. We can change this to simple sparks. like so, or you have the option of right-clicking on the emitter, going under emitter, and choosing rename emitter, and then you have a window you can enter a name into, however you want to do it. Okay, next thing is I want to get rid of this absolutely terrible texture that has been applied to each of our particles. That looks awful. I'm not a big fan. So I'm going to expand the required module properties. And this is a list of properties that will come standard on every single emitter that you create. They're necessary. They are required. The very top one we have is the material. Now to change this, we need the help of the generic browser. So I'm going to click on Show Generic Browser. And the material that I'm looking for is within a package that ships with UT3 called NV Effects. So let's go to File, Open. I have an effects folder. Let's double-click that. And then we have NV Effects, and I'll click Open. Give that a second to load in. Now, the particular material I'm looking for is called MEFX Particles Flare 01A. I'm going to use my filter, and I'm going to filter this down to Flare. And we should see this right here. I almost lost it. Thank you. So we'll go ahead and select this. We'll close our generic browser, and then I'm just going to click.
Wait, before you hit it, don't panic when everything disappears.
Oh, but I was so going to scare everybody. I was going to act all panicky. So we click here, and our particles immediately disappear. Don't worry. They are supposed to do that. And I'm going to show you why before we go any further. For now, let's go ahead and close Cascade. Let's go back into the generic browser, and I'm going to double-click on this material that we just added to our particle system. Now, once the material editor loads in, which will take just a moment, I'm sure, there we go, we can see that we have a very special type of material expression added into this material called a vertex color. A vertex color is here to listen for information from Cascade. There is actually a special module we will need to add into our particle system, which will send a color to this node, and then the color will be input into the material. Now, the problem is, on our end, if I come back down to Zach's particles and I reopen our effect, I need to clear out my little filter here so we can see that. Let's go back into Cascade. We have no module handling our color.
Ooh, and Zach, that is an excellent time to jump in and talk about modules.
That's right.
Because at the moment, all we've really talked about so far is the emitter itself. This is the guy responsible for emitting the particles. But in order to create a great-looking effect, there's a lot more involved than just putting points out to the screen. We've got to be able to control how they're moving, how long they live. Do they randomly die off at different times? What size are they? How do they move? There's a lot of different things that we need to control. And up underneath the emitter, you'll see these 3 dark gray boxes. These are modules. And it's through a series of modules that will get the actual look of the effect that we're designing. Now, by default, with each new emitter that you add into the emitter list, you will always get these 3 modules.
Now, real quick, what is a module? In essence, it's just a collection of properties. If you created an emitter that had every single property that you could possibly ever need for a particle system, that it'd have millions of, well, I guess not millions, but thousands and thousands and thousands
You'd have
of properties.
tons of particles. To be a little bit more simplistic, a module is nothing more than a black box designed to affect one specific aspect of the particle system.
That's right, and you're going to add them in based on the properties that you need.
Actually, let me get a little bit more specific.
Uh-oh.
It will affect one specific aspect of that emitter.
That's right, because you're going to be adding these on a by-emitter basis.
That's right.
Not on a particle system basis. Okay, so starting at the top, we have some modules that came in. We have lifetime. This controls how long our particles are going to live.
Has nothing to do with color. Next.
Initial size. This controls how big they are when they're born, which is the moment they're created.
Nothing to do with color.
All right, and then we have initial velocity, which is the speed they have when they're created.
Nothing to do with color, so we need to find a module that is going to affect our initial color.
Well, we can add a new module if we right-click here on this emitter. Now, we have this big, long list of all of the types of modules we can create.
You'll notice of categories.
Yeah, most of these will have submenus with the various modules that we can add. If we go under color, we have a few modules we can add to control color. We can have an initial color, which will control the color at birth. We have parameter color, which means maybe we want to send out or have access to the color from Kismet or Matinee if we wanted to animate it or change it somehow in-game. We have color over life, which will change the color throughout the life of each particle. And then we have scale color over life, which will be kind of like a multiplier effect to an existing color. What I'm going to go with, for simplicity's sake, is just initial color. And as soon as I do that,
we get the auto-save.
and there we go. As soon as that happens, we suddenly get our particles again. So let me go ahead and zoom in on our effect. And it looks like we have a whole bunch of little suns popping out of the center of our emitter.
That's right. Just a minute ago, without having the initial color module, we had no information that we could provide that vertex color. So we simply had no color that could be shown on the particles themselves.
That's right. This initial color is being sent into that vertex color, which is then going into our material, which is then firing back out into our particle system.
And you can see a color set down here up under the distribution, up under constant. And actually, if you want to get technical, we can go up one higher, which is up under the start color.
That's right.
But we see this XYZ value all set to 111. And XYZ, well, that's going to represent RGB.
That's
so
right.
A value of 1, we're dealing with white, and what do you know? We now have white colored sprites.
Right. It's because constant values are generic in nature. So instead of changing them around so that you have one that's RGB and one that's XYZ, we just assume that X, Y, and Z represent RG and B respectively.
That's right. Okay, excellent. So now we're seeing particles on the screen again.
All right. So now let's go ahead and start playing with some of the properties that we need to create our effect. The very first thing I'm going to do is come back up to our required module. We weren't quite done with this. So I'm going to expand this. And the next property we have underneath material is screen alignment. Now what this does is this controls how these sprites are aligned in respect to your monitor or to the screen when you're playing the game. If we expand this, we have square, which is the default. This just means that the sprites will always be square in nature. As a side note, if your particles are set to square, you really only have to worry about their size in terms of the x-axis. Because when you change x, well, y will automatically update to maintain a square. But if you use rectangle, you can have two different measurements. You can have an x and a separate y so that you can start creating rectangular or more stretched particles.
And this will make more sense in just a minute when we get over into the initial size module.
What we're going to use is PSA velocity. And this is a very special type of alignment in which the local x-axis of each sprite, the vertical axis, will always be pointing in the direction that the particle is traveling. So let's go ahead and activate that. Now you won't notice any change here because each of these sprites has a texture that's a perfect circle, so you won't see anything just yet. But it's going to be important later on as we roll through. Let's go ahead and start adjusting some properties. I'm just going to move straight down my list of what was already supplied. So we'll start off with lifetime. And this is currently set to a min-max of 1, which means that every single particle is going to live for 1 second. I'm going to set our maximum to 2 so that our particles are living for a random range between 1 and 2 seconds. Excellent. Now moving down from here, we have our initial size. Currently this also has a min and max. Notice that both of the values for x, y, and z are set to the same thing, so this is very much like a constant value. Now, let's talk a little bit about that. I'm not going to go too far into distributions. That's something we're going to save for a later video. But a distribution is essentially a type of information that you can store in any given property. That's a really simple way to put it. Right now we are looking at a uniform distribution, which is going to give you a random value in between a min and a max. Now what I'm going to do is I'm going to change this from a vector uniform to a vector constant, which is just going to give us x, y, z, no min and no max. And I'm going to set this for now to 2 by 2. Notice I'm not even going to worry about setting z because we don't need that third axis. That would be important if maybe we had a mesh emitter and we were handling a three-dimensional object such as a static mesh.
Right, and to bring your attention back to the setting that Zach did just a minute ago back in the emitter itself where he changed it over to velocity-controlled size as opposed to being square. This is what I was talking about when we got over to initial size, that you'd make a better understanding in your head of what was going on. When we're using square, only the x value is taken into account. So by adjusting the y value there, we would have not affected the particles whatsoever with the size.
That's right, but because we're using a velocity-based orientation, if I maybe set this up to 5, we're going to start getting particles that are starting to stretch out just a little bit, which you can just barely make out. Maybe we can really push that up to something like 20. And now you can see how they're really starting to stretch out. But for now, I'm going to leave this at 2 by 2, and that'll be our initial size. Okay, now moving down from here, let's take a look at our initial velocity. Now, for initial velocity, the effect that I'm going for is a fan of sparks that are firing along the local x-axis of the emitter. Now, if we take a look at the initial velocity parameters that we have available by default, we have a random value between -10, -10, and 50 for x, y, and z in our minimum, and then our maximum is 10, 10, and 100. If that's confusing, break it down on an axis-by-axis basis. X is going between -10 and 10, which is creating kind of a nice fan to the, in this case, forward and back. If I rotate my view around by dragging with the left mouse button, it's giving us a nice fan to the left and to the right. Y is giving us a nice fan now to the left and right after I rotate our view around. The two values, x and y, are giving us a cone of particles.
So we're just simply pushing particles out of the emission point, and we're giving them a velocity, an initial velocity of the -10 to a +10 in the x direction, which creates the start of this cone. And then in the y direction, a -10 to a +10. So now we've got this perfect cone in regards to the xy plane. But then in z, we're pushing things a lot harder, going between 50 and 100, and that's why we see all of our particles going upwards so quickly, but they are spreading out in the cone that I was just describing with the x and y plane.
That's right. Now to get these to fire basically down the x-axis, I'm going to set my min for x to 75, and you'll notice a change in direction already. We'll set our max for x up to 150. So now we're shooting primarily down the x-axis, and if I was to rotate around our particles, that becomes a lot more apparent. Let me aim this right down.
Let me point this out every time. As Zach is rotating around, one of the things he's wanting you to look at is this origin over here, so that you can see x. Now we're traveling in the x direction. So as he rotates, go ahead and rotate, Zach. You can see how we're pushing out. That's right. It's following that x-axis.
As a matter of fact, just to really help make sure that nobody ever gets confused, I can go into the view menu and we can turn on the origin axis.
Now look at it.
And that's going to stick right to the particle emitter so that you can see really where we're pointing.
And as a matter of fact, right now, if you look at it, we're pushing strongly in x and in the z-axis, and that's because z still has a really strong number down there in the start velocity as well, where we're going between 50 and 100. And so that's kind of why we're splitting it right now between x and z, but there still is a little bit of variation if we rotate around a little bit more so we can see y. There is still a little bit of variation back and forth, left and right now, when looking down y.
That's right. So what I'm going to do is I'm going to increase that for y, let's say between -50 and +50. So now we have a random fan in the y direction. And now I'm going to pull down our amount in z, because we're still firing upwards a little too much for my taste. We're going to set this to 10 and 10. So there's really no random value. It's just going to be shooting slightly upwards by a value of 10.
So now, which of the start velocities have the strongest numbers, if you will? X does, with it going between 75 and 150, and that is why the particles are now favoring the x-axis more than any of them.
Now, a quick note, if you're jotting notes down, there is a reason that I chose to fire my particles down the x-axis. That is going to become important later when we try to aim our particles in the viewport. You'll see why. Just remember I said that.
That's right. Keep that in mind.
Okay, now that's all for our initial velocity. Let's take a look at initial color. I have an orange color in mind, so I'm going to set my constant values here to 1, 0.4, and 0.2. And again, that's just controlling R, G, and B in place of X, Y, and Z.
Put Y and Z both at 0 for a second.
Okay.
Let's make this very easy for them to see. Ta-da!
They're red.
X is now 100%, and there is no green and blue.
And if we set maybe X to 0 and Y to 1,
go away,
now they're green.
Now they're green. So we've got all and Y.
So we'll go back to our color, which is 1, 0.4, and 0.2, which is kind of orangey.
Yep.
In fact, if I pause, you can see that, because when they're moving, it's a little tricky to see.
A little bit
sometimes.
of white in there to indicate that they're hot. That's the whole idea with sparks.
And by the way, if you're worried about the material not glowing enough, don't worry. It doesn't glow much in this window. It's going to look better later on. All right, now we are done with all of the modules that we have up to this point, and amazingly enough, our effect doesn't yet look very sparky.
No, it doesn't.
So the next thing we're going to do is add another module which will control the size of our particles based on how fast they're going, and that is a size by velocity module.
Okay, so this may look scary when he first brings it in. Hang tight.
Bing.
And, oh, yeah, we got to hit play.
Yeah.
Velocity is very important now.
Boom.
Wow, we've introduced a streaking sun into the preview window.
Look, it looks cool, but it's not at all what we're looking for. And that's just because the basis of size by velocity is really blowing things out. The first thing I'm going to do to counterbalance this is
You saw the word velocity multiplier.
That's right. We're going to go down to initial size and pull this way down to 0.2 by 0.2. So now we have these, still larger, but still fairly small little puffs of particles. And now we'll go down to size by velocity, and we're going to use this to, again, change that size based on our speed. For X, I'm going to use 0.05. For Y, we're going to use 0.4, and then Z, which we don't really need, I'm going to set to 0. Now, what is this doing? This is multiplying our size along each individual axis based on our speed. So if we take Y and maybe set it to something atrocious like 5, we start to get this sort of laser spike-like effect, which looks really bad coming out of the emitter, but out here it looks kind of cool.
Mm-hmm.
Now let's set this back to something manageable, though. Now that we've demonstrated it, we'll set it back down to 0.4. And we're already starting to get a very spark-like look. But we don't yet have a very spark-like behavior, because sparks don't just fly off into the ether, never to be seen again.
Well, not here on planet Earth, where we have things like Gravity.
That's right. We need gravity. Now, we don't have a gravity module, but what we do have is an acceleration module. Unfortunately, gravity is just a force that accelerates objects toward the ground. So we'll apply this. Let's go ahead and take a look at its properties. Now, its properties by default are set to a special type of distribution, as we mentioned earlier, that goes between a min and a max. It's going to give us a random range. We don't need a random range.
This particle just kind of floats down while this one
goes faster than that one. That's right. We don't need that. And rather than waste the time on or the resources on having a min and a max we set to the same value, I'm going to change this over to a constant because, as we all know, gravity is a constant force that accelerates objects toward the ground at 9.7 meters per second. So we'll set this to -200, and there we go.
Hey, we've got gravity.
So now our particles are starting to fall down toward the Earth. Now this is all well and good, and things are looking really nice.
They are.
I'm trying to figure out, though, should we go ahead and talk about doing the burst like we had in our first video? Because, it wasn't just constant in that first video.
Yeah, let's go ahead and get this in the level. Let's let them see a very basic particle system that they just set up. How do we get in the level? What do we do next?
Well, at this point, if you're satisfied with your work and you don't ever want to lose it, we need to go to Edit and save our package. And it is really nice that you can save your package in here without having to go back to the generic browser.
And notice he just had a browser pop up asking where you'd like to save the package. And he was up under Effects. Keep that in mind, just in case you happen to put your package elsewhere, then you forget, where did I put my package?
Yeah, always remember where you save your stuff. All right, let's go ahead and close Cascade at this point, and we'll leave the generic browser open. Notice that my Simple Sparks particle system is selected. Then I'll close the generic browser. Let's right-click on some surface in the level, and we get Add Actor. And because we have a particle system selected, we get the option to add an emitter, and you'll see the name of your particle system there. We'll click on this, and we are awarded with the emitter actor, which is a special type of actor whose only job is to transmit particle systems into your level. Now, one thing I want to show you before we do anything else. This guy has a directional arrow. This arrow points down the local x-axis of this emitter. That's why it was so important for us to use the x-axis to fire our particles down. For a demonstration, let's go to real time. Sounded like a news broadcast.
And the reason he's saying it's so important, it's not that would have really affected or messed up anything with the particles if we would have chosen the y-axis or even a split between x and y, but in this particular case, Zach is able to position the particles in our level without turning on real-time mode, just by using that arrow as reference as to which way the particles will be going, since he's designed the system to have the particles being pushed out along the x-axis.
Well, if you'd used y, you could pretty much always assume that your particles are going to fire out to counterclockwise right of wherever your arrow is pointing. If it's Z, it becomes a little trickier.
Counterclockwise? Clockwise.
It's clockwise. Okay. Yeah. Well, no, not anymore.
But the arrow.
Absolutely. It's easiest if you just sight it down the x-axis, which is why I wanted to drive that home. So let's get this positioned, and I'm going to do that with the help of the orthographic views, which, if you're not impressed by that, you don't know me personally, because I never use orthographic views. I live in perspective.
I'm surprised you're over there myself.
Yeah. Now, you'll notice one other thing, too. My particle system is not snapping. That is because currently my drag grid is set to off. I don't have it active because I didn't want snapping for placing this guy. Okay, now we have it in pretty much the location that I want it. Let's go ahead and rotate it. Over here in the top viewport, we'll tap the space bar to go over to the rotation widget, and we'll just rotate this around to fire forward. Let's go into the side view, and I'll rotate this downward.
So it makes more sense.
And then, maybe back up just a little more than that. I don't know. So, there we go. Because the gravity really is pulling that down a lot. Okay, now let's blow our perspective window back up so we can see, and I'll deselect my emitter just so we can get an idea of what things are looking like. In fact, I can hit G to go into game mode and get a pretty clear idea of what this is doing. You might want to fine-tune this a little bit.
Fine-tune it for me. You can do it right here in the perspective mode. I'm not going to lose any respect for you. It's going to be okay.
Well, I wouldn't do it because wait, okay, just for example's sake, we're going to put it inside the mouth because that looks cool.
I wouldn't do it.
No, do it. We're going to do it. We're going to do it as an example. Also, notice I'm moving in local mode, so you can see that my axes are a little bit skewed, but that's totally cool. And maybe, let's see, does it need to be centered up just a tad? Yeah. So there we go. Now they are literally firing out of the mouth of our dragon, and that's going to be an interesting thing here in just a few seconds. So we have our effect in the level. We can preview it. The cool thing about doing this is that now we do get to see the full force of that glow effect.
You'll notice it looks a lot nicer than it did over in the preview window inside of Cascade.
But there's a couple of things I want to add to the effect before we call it quote-unquote done.
And how about, for starters, showing them how they control the actual emission of particles? Like, how many per second are being fired out?
That would be cool.
Because obviously that's kind of important. So someone might say, well, what if the particle system that I'm creating doesn't have the default rate? What if I need more particles or less particles? So let's start there. Then we'll work from there over into bursts of particles.
Okay, well, let's go back into the generic browser. We'll double-click on our Simple Sparks. And just for safety's sake, I'm going to turn off real-time.
I'm just going to ease the system up because there's a lot going on right now with the recording of this video and everything else.
That's right. So we'll switch off real-time because we get a nice preview over here anyway.
Right.
So the first thing I'm going to do is select my emitter. We'll expand the required module. And if I scroll down past all of these various properties, which we're not going to be going over each one of these right now, we see the spawn rate, which is quite possibly the most important actual property in here. Now, by default, this is set to 20. If you want, you can set this to, 100. And we get a whole lot more particles. Now, the cool thing about this is going to be reflected over in your level. So if we minimize Cascade for just a moment, I'll close the generic browser. Let's turn on real-time for just a second, and we get a lot more particles.
A shower of sparks.
It looks fantastic. Now, I would recommend you don't get too happy with this. I mean, I think we could probably easily go as high as like 500 or probably a lot more, but don't go in there and put like 500,000 at some point.
But what exactly is this spawn rate? Obviously, as Zach's making the number larger and larger, we're spawning more particles, but what is the number? It's the emission of particles per second. So if he sets this to a value of 1, we can prove this. So 1, so every second.
Like a clock.
You got it.
There you go.
So now go ahead and put it to 2. So now we're going to start putting one out every half a second.
And so on all the way up to, let's leave it at something like 30 for now. We don't need that many.
Yeah.
Because what I want is a pretty thin, constant stream, and then we're going to have bursts where we have a lot of particles. Now, on to the subject of those bursts.
Yeah.
And down from here, you'll notice we have a burst list. This the tooltip says your array of burst entries, and what that means is each time you want a particle to fire out a burst of particles, that is going to be one entry here in your burst list. But before we really talk about bursts, there's something else we have to talk about first, and that is your emitter duration. Your emitter is going to run for a certain number of seconds before it loops again. Now, what do I mean when I say that?
And let me throw this in there real
please.
quick, because what you said a second ago could be very confusing. Every time you want a burst, you'll add a new array entry.
Yeah.
It's not 100% correct, because you're going to keep getting the bursts every 1 second because the cycle's repeating itself.
That's right. But see, it depends on how you look at it. It's a perspective thing.
Right, and that's why I didn't want this to be confusing.
That's right. Okay, so let's just start with emitter duration, and then we'll work our way up to burst. Because emitter duration allows you to control how long your emitter will run without in one single loop.
That's right.
Some effects will not be constant, like this shower of sparks we have here. Maybe you'll have like an explosion or just a pop of particles where you won't be looping all the time. Now, in those cases, you won't want your effect to keep cycling the way this is. Emitter duration allows you to control the length of one cycle. By default, this is set to 1 second. Now, keep that in mind. Just knowing nothing but that, let's come back down here to the burst list. I'm going to add an entry to our burst list by clicking on the Add Item button, and we get entry number 0. If we expand this, we have 3 separate properties. We have count, count low, and time. Count is going to be the number of particles we want to see bursted. Let's just set this to some nice value like 100. Press Enter, and immediately we start getting something fairly interesting.
Ooh.
We get bursts of 100 particles. Now take note of their time. How often are they coming out?
Looks like every 1 second, Zach.
That's right, once a second. We are getting one burst during every emitter cycle, and that cycle is taking place over 1 second.
That's right.
So let's come back down to our burst for a second. Let's say we don't want there to always be 100 particles per burst. We want a random range. If we take count low and set it to anything other than 0, we develop a range. So let's set this to, say, 60. Now we're going to get a random number of particles between 60 and 100 with every single burst. Okay, down from here we have time. Time is an interesting property because it's going to be a 0 to 1 value based on the overall duration of your emitter.
Yeah, you need to do some mental mapping here to make this make sense.
That's right. Now, by default, our emitter is set to a 1 second duration. So really, it's going to work exactly the way you'd think it would. If I set this to 0.5, we get our burst half a second into the emission. In fact, if I restart my simulation...
Watch carefully. You're not going to get the burst as soon as he hits restart. boom,
half a second
later.
Half a second in, it starts up. But then at that point, they're still firing off at 1 second intervals.
That's right. Now set it back to 0 and restart it again. Let's go ahead and really drive this point home. So restart, boom. Instant burst.
That's right. As soon as the emission starts, we get our very first burst.
And if Zach puts it up to a value of 1 and restarts one more time, you'll notice there's a 1 second delay before the first burst. Let's go ahead and restart. And here we go.
And sometimes it doesn't like it when you set it all the way. It's just something I've noticed. Let's try just 0.9, and then it'll go right at the very, very end. Okay, so there's a quick look at time. Again, it's a 0 to 1 kind of thing, and you'll notice sometimes when you set it to 1, it gets a little bit funny. So set it to values like 0.9 if you need it out toward the end. Now, with that understood, let's jump back up here to duration.
Let's change that emitter duration to 2 now.
All right.
So now, watch, it's going to be every 2 seconds. See? But the value we're dealing with back down in the, here we go, burst section, 0.9. Remember, that's like I said, it's a mapping that you need to do in your head, because 0 to 1 in this particular case is now mapped for the duration of 0 to 2 seconds.
Well, in short, just think of it like a percentage. Where it really, if you set this to 0.5, it's halfway along your duration.
There you go. I like that.
Whatever your duration is take half of it. I'm going to leave it at 0 for now.
So we instantly get...
Yeah, just because that's nice and easy. And because we only have one burst, it doesn't really matter where it takes place. And
let's go ahead and throw this in. Just a second ago, you saw Zach restarting the simulation. This is actually a very important thing to do when you go in here and you start making adjustments, especially when you make some sort of property adjustment and you do not see a change in your viewport.
Yeah.
Sometimes you just need to go up there and restart the simulation for that property to be taken into account. So remember, if you don't see the change that you're expecting to see, go up there and restart the simulation.
That's right. Okay, now let's jump back up to emitter duration. Now that we have a pretty clear understanding of what bursts are doing, sometimes maybe we don't want our duration to be the same with each cycle. What if we want a random range? Well, there's several things we have to adjust. First off, we have emitter duration low. This gives you the lower level of a random range, so we could set this maybe to 1, and based on what we know from the burst list, you would think that would give you a nice random range for your emitter duration, but it doesn't. There's actually something you need to do first. We have B, emitter duration use range. That sounds nice, so we turn that on, and now we have a random range. Just to really make sure you understand what it's doing.
Actually, if you just watch it, 1, 2, boom, 1, 2, boom.
Let's set it to 5.
Even if you do that, there's an interesting thing that's going to take place here. It is going to randomly generate a number between 1 and 5 in this particular case, but then it's going to keep using that recalculation.
And I can prove it. What we're going to do is call on some of the information we can pull out of the view menu. I'm going to come down to particle times. Now, what this is doing, I'm going to pause for just a second so the numbers will quit jamming. And I was going to...
There you go.
We'll get the particles out of the way. On the left, we have the duration of our emitter. So this duration that's being calculated in this random range is ticking along on the left-hand side of the slash mark.
And remember, what he means by duration, basically the emitter is going to fire, and we're going to hit the end of the cycle. And then it's just going to restart the next cycle, and it's just going to keep looping, if you will. So this is how long we are along in the current cycle in its duration.
That's right. And on the right-hand side, we have how long since the thing has been running. So really, this has been running for 15 seconds. If I restart it, the number on the right will go to 0. So will this. This will tick up to the total duration. This will just keep right on counting.
That's right.
So let's go ahead and just restart, and you can see that happen.
Here we go. So 1, 2...
Now, watch this number really closely. Now, I know that we're probably not capturing anywhere near real time, but what we're seeing over here is that we're counting up to 2.5 or so, 2 point some change.
Yeah, 2.6, and it resets to 0 every single time, even though Zach has set up a range of 1 to 5.
Right, so it's doing a random range, but it's not recalculating that random range each time. So we need to activate B, duration recalc each loop, and now that random range is going to change each time the emitter restarts its duration calculation.
Yeah, so there, first time we made it all at 4 seconds. The second time we made it up to 3. There we made it up to 3 again. 1, 2, 3. Up 3 again. Hang on. 1, 2, 3. A little higher. Oh,
there you go. So you can see that duration.
There was 4.
I
saw 4.
There you go. All right. Now what I'm going to do before we leave out here is I'm going to add one more entry to the burst list, so we end up with a second burst.
Do one at like 0.2 and one at 0.8.
All right, well,
20% along and then 80% along. But now since he's randomized the range, we're going to get bursts at very unpredicted times because now he's got 2 different burst times, and he's bursting, 60 particles here? Well, between 40 and 60, and the other one was between, 60 and
160.
Yeah.
You can see the numbers right here on the property.
And then he's saying that, in one of them do the burst at 20% way along the duration, the other one do it at 80% along, but now since we're randomly changing that duration every single cycle of the particles, we really start to get a random burst distribution.
That's right. So just remember, if you really want to randomize things, you need to not only set up your emitter duration low and your emitter duration, you also need to check duration, use range, and recalc each loop. So make sure all of those are on.
And if things don't look like they're working right, make sure to restart your simulation.
That's right. Okay, so with that, we have the
let's take a look back in our level.
emissions that I'm looking for. Yeah, let's go ahead and close this out. I will, before we leave out here, we'll resave our package just to be safe. And we'll close out of here, and
we got a burst.
All right, looking good, but there's one more thing.
It's all going. Can we go up into the floor and see them under there? Yes, we can.
Yes, we can. We see particles falling way out of our level.
Not that that's a problem, but what if we wanted to have the particles actually collide with the floor, perhaps die or bounce?
Did you see that back there?
Whoa, that's pretty scary. Let's pretend I didn't see that, right?
It's no big deal. Apparently, I had this piece of the floor selected when I grabbed my flare material. So I'm going to Alt-right-click on this part of the floor and Alt-left-click over there to replace that.
Okay, now I'm not as frightened.
Okay, so
I'm just kidding.
What I want, yeah, you're still frightened, of course. What we want to do is have the sparks hit the floor and perform some sort of a bounce.
That's right.
So let's go back into the generic browser. We'll open Cascade back up. And this is really simple. All we need to do is add a new module, which will be the collision module. And that's really it. Believe it or not, we have some sort of collision taking place, which we can immediately prove if we get rid of the generic browser, and we're not spitting anything out right now. That's kind of scary. So why is that? What's going on, Jason? I'm not afraid, are you?
Yes, I am afraid. You broke it.
We have put our emitter inside a static mesh, and so we're actually colliding with the inside of the Dragon's mouth.
In case you guys didn't realize this, a minute ago when he said, but we're going to have a problem when we put this in here, that's what he was getting at. He just never finished his sentence.
That's right. Well, I wanted to get everybody surprised. So now
it's dripping off his teeth.
You pull it out a little bit, he's drooling, and then if we pull it out all the way, he's spitting.
There you go. Very nice.
So you could make adjustments to the static mesh's collision if this was a real major thing.
Sure.
In a lot of cases, you'll find that it probably doesn't matter so much to just leave it out a little bit. It's still going
it looks good.
It still look good to your player.
Now let's go down to the floor and look up underneath it again.
All right. Well, if you go down under the floor, I'll go right under it.
Look at that. So we have no bouncing because we haven't set up any sort of bounce condition, but
the particles are dying when they hit the floor.
Right. They are.
As a matter of fact, if you look really close, you can see them die. They'll hit the floor and then immediately just start to fall. You can just barely make it out. It might not even show up on the video. But what we want is some sort of bouncing to take place. So we're going to go back into Cascade and take a look at the properties of this collision module. And the very first thing we have is damping factor. This controls how much energy your particles will retain after colliding with a surface. And with a value of 0, they're retaining no energy, which means they're more or less just falling flat and not moving anymore. What I'm going to do is change this to a constant value. I really don't. Well, we can do a random range. I don't see why not. But let's maybe start off with a maximum of 0.5. I hadn't thought about using a uniform, but we could do it. And then we'll do a minimum of, say, 0.2. So the weakest amount of energy that our particles will have after they bounce will be 0.2, which is 20% of their overall energy, and the most amount they'll save is half of their energy, or 0.5. So with that, let's minimize and take a look again.
Hey, groovy. We've got bouncing.
And we get all sorts of really cool bouncing taking place, and because we have that random range, you can see different amounts of bounce coming out of each one.
Yep, very nice. And the burst is really cool.
Yeah, it is. I wish it would happen maybe a little more often.
Well, gee, with a range of 1 to 5.
That's true. I could probably go back in there and fix that.
Probably, yeah, maybe.
Jump back down to our emitter duration,
3.
set that at 3. I was going to say maybe 2, but now we'll get a lot more burst, a lot more burst per buck.
As it's shower.
There we go.
And it's coming, maybe. There it comes.
And really, with that is the entirety of this effect. Now, we did promise you one more thing before the video was over, and that's that we would walk you through the Cascade user interface. And now that we have a particle effect that is visible for us to take a look at, we can do that, and you can see some of the things that are actually going on. So for starters, let me go ahead and turn off particle times for now. We'll just keep our little spray of particles
visible. As a matter of fact, let's go ahead and just pause the particle system at the moment.
Sure thing. We'll just click pause.
All right.
Starting at the very top, we have the menu bar with the edit menu. This has regenerate lowest LOD as the very first entry. In order to explain this, we need to go into a discussion of LODs, which I'm going to save until we get to the toolbar. So don't worry, there's actually a button on the toolbar which performs this operation, so we'll explain it then. For now,
We'll be right back.
Yeah, for now, just roll with us. We have the save package, which I'm sure you all know what that does. We've already used it.
Of course, it's just a shortcut way of doing it here as opposed to jumping back to the generic browser and saving your package with the particles in it.
Which is great if you have Cascade maximized like I do. Under the View menu, we have all sorts of stuff that we can show in the view to help us diagnose certain aspects of our particle system. We can view the origin axes, which if we take a look, these are visible on the particle system right where it's being born. It's just the local axes of the emitter itself. We can come down under here. Let's turn that off. We have particle counts.
All right, go ahead and hit play now.
Okay, yeah, I was going to say just to make it change. Boom, there you go. Now what this gives you is two numbers. The number on the right is the maximum number of particles that will be in this system. Like if this thing fired the most number of particles it could possibly fire, we'd have 390. On the left, we see the number of particles that are actually in the system. So you'll notice it gets really high, and then it'll die down as particles start to decrease.
With the burst, it jumps up quickly.
That's right. So 606 has changed because the highest number has changed. Like this is keeping track of the largest number that have been in the system so far. All right, moving down from here, let's turn that off. We have particle times. Now, I've already demonstrated this, but on the left, we have the emitter duration for this particular cycle. On the right, we have how long this simulation has been running. If I restart, they both set to 0. You'll notice the one on the left will keep restarting when each duration is over. The one on the right will just keep right on counting. All right, now let's turn that off. View particle distance. This is non-functional. We have view geometry.
At this time.
At this time. As of right now, this property does nothing. But, okay, we have geometry, which gives you this really cool sort of half geometric, half terrain-based mesh that is in your particle.
Some organic, some not so organic.
And this is a way for you to test collisions. Now, currently, as you can see, it's fairly useless for our effect because we're actually starting off underneath the level of the floor. To fix that, we need to go into View and open up our geometry properties. Now, let's go ahead and just kind of collapse everything down. If I open up primitive component, you'll see translation. And if I take Z and maybe set it to -150, boom, that pushes our geometry down. So now our particles are up above it, and you can see them hitting the ground and starting to scatter down the hill.
Yeah, actually, if we had a very complex level taking place back in the editor, it would be a lot wiser to work with bouncing, collision, and all that right here as opposed to going back and going into a game mode over there and watching real-time updates.
It just saves you time and effort.
It does.
And it looks really nice. But anyways, when you're done, let's go ahead and close out the properties. And I don't think we necessarily need to see geometry anymore, so we'll go ahead and close that. Underneath this, we have Save Cam Position, which sounds just a tad misleading. What this is going to do is actually take a snapshot to be used in your generic browser. So if I minimize Cascade here, and let's open the generic browser back up.
There it is.
If I take my view and set this up to 256, you can see that the view I had in my preview window a second ago is now the thumbnail for my particles. Okay, back into Cascade. I think we're now on window. What this is going to do is show or hide various panels of Cascade, so we can hide the properties area, hide the curve editor, or hide the preview window. I generally leave these on at all times. All right, now down to the toolbar, and this is where stuff gets really cool and interesting. We have two restart buttons. We have Restart Simulation, which we've already seen. We use it to just restart what we've done so we can start the count at 0.
And I've tried to drive home the importance of using that often when changing properties.
Absolutely. And then to the right of this, we have Restart in Level, which if I take my Cascade editor and kind of scoot it out of the way, and we'll take the generic browser and close it, you'll get to see something kind of important. If I turn on real time over here, we have particles firing in both windows. If I restart with the blue button, we get a restart in one window, but not in the level. If you click Restart in Level, everything restarts.
There you go.
So just a quick indicator there. Let's turn off real time here inside the view, and we'll come back over into Cascade, nice and big. Okay, next, Save Thumbnail Image. It's the same as Save Cam Position, except this actually has the proper name, and I just messed up my layout. Let's fix that. All right, now moving over, we have Toggle Orbit Mode. This really isn't going to make any sort of change. What this is supposed to do is take your control and change it from orbiting around your particle system.
You can move around.
Yeah, to a more freeform mode, but it doesn't really change anything at this time. So it's kind of irrelevant. Now, next to this, we have Toggle Wireframe. This will just show you the wireframe of your particle system.
All of our boxes are stretched.
That's right, very cut and dry. And from here, we have Toggle Bounds. This is going to show you a bounding box and a bounding sphere that completely encompasses your effect. Now, if I restart, you get to watch this thing actually grow as our particles move around, and that'll fluctuate a little bit from time to time. So again, if you just need an idea of the overall scope of your effect based on a box or a sphere, that's how you can get it. So I'm going to go ahead and turn that off because it's kind of disconcerting. Now, we also have the ability to turn on... Oh, I did it again.
You sure did.
We can turn on various... what are these? Post processes. Thank you. So we have a list here. I'm going to show, let's see, depth of field, and you can see it just kind of blurs out the view. It's kind of like squint mode. And if you've been wondering, why does he keep messing up the UI? If you click on this title bar for preview, you'll do that, and it's just because I'm having to click on every button I occasionally miss.
And he likes to hit that mouse button with enough force to drive a nail into a 2x4.
And I'm trigger happy, so it just comes from playing UT just a little bit too much. All right, so next here we have toggle grid. So it just shows you a grid in the preview window.
Need a grid?
If you need one. So let's go ahead and turn that off. Next we have play and pause. Very cut and dry and pretty obvious what those do. Next we have the speed controls. Now, an interesting thing about the speed controls, they're pretty obvious what they're going to do. Set it to 50, you're getting 50% playback.
Watch very
25,
carefully.
Down to 10. Okay, I'll quit.
Look at our particles. They seem to be getting smaller.
They are getting shorter.
So we are truly affecting the velocity.
That's right. Remember, we have set size by velocity. So velocity is controlling our size. The slower our particles go, the smaller they get. We go down to 1%, they turn into dots.
Small, yeah.
So let's leave that at 100%.
So even though it's slowing it down, it's truly slowing it down.
Yeah, that slowdown is being calculated in the creation process. All right, moving over from here, we have toggle loop system. So if you have a particle effect that is not intended to loop, like a one-time only burst, you can turn looping on and off here. We have toggle real time, which if I turn this off, it looks like we've paused. But if I start moving the mouse, we'll start noticing motion. So every time I do something to update, we'll see a little bit of motion here. I just leave this on. All right. Next, we have background color. Pretty obvious what this does. We click here and choose a color, and that appears in the background. So you can test your effects against a variety of different colors.
Yeah, it can be it can be very useful when you're working with different types of transparencies, different types of effects.
Exactly, especially things that are supposed to glow or, like you said, have multiple levels of transparency.
Right.
Let's go ahead and set this back to our little native shade of gray, though. Now, let's jump over to toggle wireframe sphere. This gives you a sphere radius, which I'm going to set to, 64 for no reason. For no reason at all.
It's a sphere.
Yeah. This is all it does. It shows you a wireframe sphere if for some reason you feel like you need to see one. So, if you need to get an idea of radius distances from your emitter, it can be a good way to measure and give you an idea of scale. So let's go ahead and turn that off. Next we have undo and redo, which is pretty obvious what those do. I'm sure you use them all the time on some level, but there's the buttons for them. There's performance check, which currently is non-functional. So you can click it all you want. It's not doing anything. All right, now from here to the end of the toolbar, we have level of detail controls.
Now, do we want to come back to level of detail at the end of this?
I do. I don't want to go over it right now.
So, yeah, hang tight. We'll come back to it at the end of this video because we'll set up an example with our system here.
That's right. Okay, now, moving from here, we have the preview window, which we've already gone over. We have the emitter list, which we have sort of gone over, but not entirely, in that we have some controls that we haven't really discussed that are here on the top of the emitter. We have similar controls that run down the sides of each module. Let's talk about what these do. First off, we have the ability to enable or disable this emitter altogether with this very first checkbox. So we kill that, and it looks like everything disappears because we have disabled this emission.
Not very useful with our current system, but if we had multiple emitters in here, which Zach's now going to show you how to do, is he's duplicated that. Now we could make some changes to this other guy real quick.
Or turn him off.
Or just turn him. We'll go and turn him back on.
Well, let's change the initial color.
Exactly.
So we'll jump over to the initial color, and we'll say 1 for this guy, 0.4 for this one, and then 0.2 for this one. So it'll be the opposite color, a shade of blue.
Okay.
Oh, complementary colors.
So now we can turn that off, and you can see how this allows us to focus on just a part or several parts of a particle system.
That's right. So if you're trying to diagnose maybe how your smoke is looking and you need to turn off your flame or your sparks, this is a good place to do it. All right, the next button can look a little bit
Let's go ahead and turn that other emitter off just for a few minutes.
Okay,
but leave it in there because we're going to come back.
It looks so good.
I hear you.
I almost want to make another one that's green.
Okay.
I'll do it later.
All right.
Okay, so our next button, you won't be able to tell what it does at first. So you just click on it, and it looks like your particles
It looks like it just killed everything, Zach.
What this does is this cycles through a variety of render modes, and they're really only useful for wireframe. So if I switch over to wireframe, here we can see our sprites in wireframe view. Now if I click on this button, we get points, and you'll notice this guy also updates to show a little point. Then we can switch it over to ticks, and ticks will also try to give you an idea of the scale, but notice in this case the ticks don't orient themselves along the rotation. So you can see they are indeed stretching along the y-axis, but since we don't have that orientation, it can be a little tricky to get an idea of what you're looking at. Then if we hit it again, we are disabling rendering altogether. Our particle system is technically still running. It hasn't been deactivated, but we've turned off the ability to render it.
That's right. Now, these render modes can be very helpful when you're more interested in working on the particular motion of a particle effect as opposed to its actual look.
That's right. Or maybe, how much space are these particles taking up? All sorts of diagnostic things where the actual sprite information or the mesh information, what have you, is misleading in some way.
That's right.
All right, so let's set this back to our default. And then we'll jump back over off wireframe mode so we can see our sparks again. Now down from here, we have the send curve information to curve editor button, or at least that's what I'm going to call it anyway, because that's exactly what it does. Now, I don't think I have any curves. Do I?
No, you don't.
No, well, okay, there's spawn rate.
Okay.
There's nothing really to graph, though, because
there's
it's constant.
So,
in this case, any properties that I have some sort of distribution on will be sent over to the curve editor.
Yeah, but like I said, you don't have any curves set up right now. We'll be focusing on that here shortly.
Okay, moving from here, I'm going to remove that guy from the curve. And this works exactly like the Matinee's curve editor. So if you need more information on using the curve editor, I highly recommend you check out the Matinee videos. All right, so let's remove this to get this out of the way. Let autosave do its thing. Now down from here, on each one of our modules, we have a similar set of buttons. We can send curves out to the curve editor if we need to. So in this case, there's the lifetime property being fired out. And then we have the ability to turn off any individual aspect of our system by deactivating
killing off
any
module. That's right.
So like I can take, let's do this. Let's go over to view and we'll turn geometry back on. And I can deactivate collision. And notice we're no longer colliding.
Our particles go down up underneath it.
They're just falling down to the floor.
Go.
But if I reactivate that, boom, we start colliding again.
Nice.
So just a way to show you that you can turn these modules off, which is great for debugging and diagnostics. And again, let me go ahead and remove this curve from the curve editor because it just drives me crazy.
So now you've talked about sending the primary information, the distribution information down to the curve editor, and you've talked about the ability to turn on and off modules. Go ahead and talk about rearranging modules.
It's a really, really interesting point. The emitter list calculates modules from the top down. That is why some of the some of the modules you get by default are listed the way they are, because lifetime is really the most important module.
Because a lot of different modules will calculate based off of lifetime.
That's right. So these are going to calculate from the top down. Because of that, you can change the order in which they calculate just by dragging these modules around and dropping them into a new location. So now we have collision technically being calculated first, which doesn't really change anything in this particular instance. Where it would, where this order really would become important is where you have multiple modules affecting a single property, like maybe color, where the bottommost module will be calculated last and will tend to overwrite whatever's above it. Now, in this case, because nothing I have is really conflicting anywhere, it doesn't really matter. Okay, so there's a quick look at that. I guess I could also talk about this for just a second. You saw a second ago how I duplicated this emitter. All I did was right-click on the emitter itself, go to the emitter list. We have several different things here. We have rename, duplicate and share. We have delete, and we have export. Uber Rain I haven't even clicked on yet. I'm just scared. It intimidates me. So,
and he honestly means that. He's said it 1,000,000 times, and he's never clicked on it.
Anytime I see the word Uber, I get a little bit intimidated. So what we're going to do is right-click on this emitter, and I'm going to go to duplicate and share. And something really interesting happens. We get a new emitter, and we can't really see much of an effect of it because they're both turned off. Let me activate them both. Now, what we now have are twice as many of these pale blue particles. Just to help everybody see them, I'm going to turn off geometry, and I'm going to set my background color to black, just so everything stands out really, really loud. And here's how this works. Shared modules are kind of like instances of one another. Changing a property in one is just like changing a property in the other, and you can always tell shared modules because they have a little plus sign next to them. So if I take, say, I don't know, let's pick on initial size, and we'll set Y to 5. Notice all of our blue particles, okay, that's ridiculous. Let's try maybe just 2.
That's better.
All of our blue particles just became really, really long, but it happened on both of these emitters. So if I wanted to just change one and not the other, I would need to basically unshare them, which in this case would mean deleting and re-adding one in.
Right.
So let's go ahead and remove this emitter. I'll just take emitter and we'll delete it. Goodbye. And there we go. Notice that plus sign completely disappears. I'm also going to set that initial size back. That's just, it's like the Uber Rain bit. It's just scary to me. Okay, so there is a quick look at our various things in the emitter list. I can't really think of anything else to hit on at the moment. So let's see where to go from here. Properties, I think, are pretty cut and dry. The curve editor, I think we've got everything. I think we're ready for levels of detail.
Okay, let's go ahead and focus on levels of detail.
Okay, what are levels of detail? Really, just in short, there are ways for you to simplify your particle effect based on the distance the camera is from the effect itself.
Camera being the player.
The player in this case. But yeah, I mean, technically it's just a camera.
Yeah, I mean, think about it. If you have a super complex explosion that looks absolutely beautiful, and now you have a lot of them going off, let's say your player is now such a long ways away that they're really small.
Right.
Do you really need your system calculating every single piece of the particle systems involved in the explosion that you can't even see because it's so far away?
Right.
No.
Well, just remember, in terms of Unreal, distance is measured in screen space.
Mm-hmm.
The further away something is, the fewer pixels on your monitor it actually takes up.
That's right.
So why would you have a really heavy calculation, super beautiful effect calculating if it's only taking up maybe 24 pixels on your monitor?
Exactly.
There's no reason for it, and that's where levels of detail come in. They allow you to set up a system by which when you get really far away from a particle system, it simplifies, and you're not seeing as much. Now, before we even talk about some of the level of detail functions, let's talk about where we can find levels of detail. If we select a particle system, we have the required module properties that appear, but these are not all of the properties for the particle system. These are just for the emitter itself. We can right-click up here, and we have Particle System. Select Particle System. This is the only way to do this. And if we select it, now we have the properties of the particle system itself, and one of the categories is LOD.
That's right.
Level of detail.
The particle system, remember, is the collection of emitters.
That's right. Now, the key property we have here are LOD distances. If I expand this, we have two separate distances. Now, what is this telling us? This means that by default, we have two levels of detail that are here all the time. We have the full level of detail and then our lowest level of detail, which at this point means if we get 2,500 units or further away from our effect,
we'll be using this level of detail.
That's right. We'll be using this level of detail.
Which we can see right now if we go up there to our LOD slider.
If we set this all the way to the right, which is to the lowest level of detail,
and give it just a second.
Well, let's try to restart.
Or maybe it's not wanting to calculate that for us.
It could be. Here's what we're going to do.
Hang on. Oh, the interesting. What do we have taking place here?
Well, I'm not entirely sure. Let's go ahead and close Cascade, and I'll just restart it.
Okay.
There we go. So now we're back. Let's take this LOD slider and we'll pull it down. There we go.
That's better.
Now, by default, what an LOD is going to control is your spawn rate, because that's the simplest thing to edit. It's just going to take that spawn rate and cut it down to 10% of its original value. So now at our lowest level of detail, we're only getting 10% of our total number of particles, which at a distance would look great.
And check this out. Of course, it's shown everything over here as being, what do you want to call this?
Noised out.
Noised out.
I always call it noised out.
Which means that right now, this level of detail that's in here is being calculated by Unreal itself. And like Zach just said, now it's slowing the emission down. It's making very few particles be emitted from this particle system, but it's also done something else. It's also come in here and disabled the collision because it figures so far away you're not going to see these collisions take place.
That's right. So let's go ahead and pop this up and take a look. Collision becomes reactivated. So it's just a quick indication of some of the things that Unreal is doing to simplify our system when we get 2,500 units away or further.
That's right. Now, we can come in here and take these noised out areas and add them back in and control what exactly takes place with our parameters when we reach that level of detail.
We can start doing some really crazy things. Not that I recommend you do this, but I'm gonna do this just for demonstration purposes, and then I'm going to fix it because it's silly, okay? We're going to go down to our lowest level of detail. And you'll notice, again, everything kind of noises out. This means that we can't affect anything here. I can select these modules as much as I want to, but try as I might, I can't click on any of these properties and change them. They are locked out. They are not accessible by me. What I'm going to do is right-click on this initial size module and enable this module. Now this module has been enabled at this level of detail. Now this has caused Unreal to get a little bit unhappy with me, but this is just for demonstration purposes only. We're going to go into initial size, and I'm going to set this to 5 by 5. Now, what does this mean? This means at our highest level of detail, we have a normal particle system. if we got really far away, our particles would get large for some reason.
Well, you weren't kidding. You were going for something that's... Okay.
It's just something that is painfully obvious.
Now let's show them how we can control at what distance. I mean, they've seen the 2500.
Let's reset everything real quick. So I'll click regenerate lowest LOD real quick.
Okay.
It's going to give me a quick warning, but it's going to put everything back the way that Unreal was originally calculated.
Okay, you didn't want to actually show them that in the viewport.
No, because that was kind of scary.
Yes, it was scary.
All right, so real quick, let's close out of Cascade for just a moment, and let's take a look at what we have here inside the view. So here's what we've got. This is what we've been working with. Let's set up a system by which when we back the camera out, maybe out here into the hallway...
The blue ones vanish.
The blue ones... Okay, that'll work. So let's go back into the generic browser. We'll open Cascade back up, and here's our particle system. Now what I'm going to do is take our level of detail, and we'll set it all the way to its lowest value. Now what I want to do is deactivate our blue particle system at this distance. So I need to, basically I need this checkbox to be active, but I don't have access to it. So I need to select this module, right-click, and enable it, and then we need to just hit this checkbox.
And you'll notice back over in our preview screen that we don't see any blue particles. No blue sparks. Now go ahead and change your level of detail all the way back.
I did want to say this real quick. You'll notice the acceleration node has quit working. Don't worry about that. It's just a catch in here. So let's go ahead and set our LOD all the way back.
We've got everything there. Now let's go ahead and take a look at the particle system properties, and let's change that 2,500 units down to something a little bit smaller. What did you say those rooms were? They were 512.
They're 512 by 512. So let's pull this down to 512 units, which means we should be standing in about the hallway.
When we get into the hallway, yeah.
All right, and I think with that we can go ahead and close this out. Let's close our generic browser, and we should be able to see this right here in the viewport.
And there it goes. Wait, nope.
It might not be showing. Let's go ahead and test it out in game, because I just don't trust the...
Actually, or we could have just done a restart simulation.
That's true.
Because it's working right here. Look at this. You'll notice that Yep, you got blue
particle.
Lots of particles.
You'll see them disappear right about here.
Get into the hallway. Get into the hallway.
Boom.
There it goes. Hallway.
So it's that level of detail kicking up. Now, generally, would you want something this loud and apparent? No. Because a player would notice, oh, look at all the pretty sparks. Oh, where'd the blue sparks come from? Especially if a burst is taking place. But in this case, it's a really nice demonstration to show you how you can switch off certain effects based on distances from the effect.
That's right. Now, of course, we can control this so it is a bit more subtle by having more LODs that we can set up. Right now, we're just going from one extreme to the other.
That's right, and that's where our level of detail controls come into play. So for the time being, let me go ahead and click on Regenerate Lowest LOD, which you might recall was also over here inside the Edit menu. And what this is going to do is recreate the lowest level of detail based on the default settings, where it's essentially just locking everything down and taking 10% of your overall spawn rate.
Yeah. And taking out anything like collision, stuff that doesn't need to be calculated.
So we'll click yes to that, and now we can take a look at some of these controls up here. Okay, the very first thing we have is going to be recreate highest level of detail by copying the highest. So, I'm sorry, recreate the lowest by copying the highest.
That's right.
So it sounds tricky, but if I hit this button and ignore the warning, now my lowest level of detail looks exactly like my highest level of detail. So now
this means that for whatever reason, this particle system, it is very important to you, the level designer, that the system looks the same in all respects. If you're close, if you're far away.
Or another way to look at it is if you don't like the automatic system that Unreal has applied and you want to change everything yourself, you can go ahead and start off by copying the highest and kind of do a subtractive style workflow where you enable a module one at a time, set it to what you want the lowest value to be, and work that way. Now I'm going to go ahead and redo my my lowest levels to their defaults real quick. And again, we've lost our acceleration, but don't worry about that. It doesn't really mean anything. It's just if I was to restart Cascade, it'd come right back. Okay, next we have the LOD slider. This allows us to cycle through all of our levels of detail. And I'm going to go ahead and restart Kismet. Oh, Kismet. Thank you. Cascade. It's the K's, you know, that K sound. All right, so if we move along here, we can control...
You can see that we can have 101 different levels of detail, from 0 all the way up to 100.
I'm so glad you said that, because I was going to say 100 levels of detail, and that's just not right, is it?
No, not really.
All right, now, if we wanted to add a level of detail, it would really amount to just dragging the slider to some number, or you can punch in a number. Like if we know we want it to be right in between 0 and 100, we can set this to, say, 50, and that will move the slider for us, or I could set this to 30, and again, you'll notice the slider move to update. And then we can click, and I'm skipping buttons here, the Add LOD button. So this adds a new LOD right in the middle. So I now have one at 0, I have one at 50.
And let's go ahead and take a look at it over here in the LOD section.
We now have a third LOD added.
All right, so now 1, so you see in the index there, we got index 0, 1, and 2. 1 represents our 50. And it is at 1,250 units away.
That's right. Something to keep in mind here is if you haven't adjusted these LOD distances, Unreal's doing some math here for you, which is really kind of nice. It assumes that your lowest level of detail will come at 2,500 units and beyond. I created an LOD that takes place in between 0 and 250, and so it cut that right down the center to 1,250.
It sure did.
If I pull this just downside to 86 and go ahead and add a new LOD there, boom, we get 1875. So even though that's not halfway between 50 and 100, it still does the math to halfway between 1250 and 2500.
Of course, you can come in here and adjust those units yourself to meet your needs.
That's right. So again, I've got 4 different stages, 4 different levels of detail I could control, and by adding these, I've got a lot of ability to control what my particle effect is going to look like as I get to all these different distances from it. Now, for our purposes, I'm going to go ahead and nuke this back out. Actually, let's not. I changed my mind. Let's talk about these buttons real quick. We have jump to highest LOD. So if I click this, you'll notice we jump all the way to 0. We have jump to higher LOD and jump to lower LOD. So if I click here, we go to 50, then we'll go to 86 because that's what I set, and then we'll go all the way down to 100, and I can jump back up 1 LOD at a time. Now this is where visibility for the video goes away, but you still have a couple of buttons left, and what you have are jump to lower, and then, there's lower, and then you have lowest LOD just outside of our capture range where you can't see it. Then we have the LOD combo drop-down list, and what this is going to do is give you a list of all the LODs you've created. Again, you can't see it on our video, but if you look just to the right of your LOD selection buttons, you'll see this. As you create LODs, that list will populate so that you can just use the drop-down to select any particular LOD. It's very, very handy. And then at the far end, we have delete LOD, which will allow you to just grab an LOD and remove it altogether.
Right.
So that's a quick look at everything in the toolbar, and I think with that, we are done with the Cascade user interface.
That's a pretty thorough look at the entire interface with the exception of our curve editor, but we've already covered the curve editor in depth back over in Matinee.
Yeah, and we're going to be using the curve editor a little bit as we progress through our next effect, which is going to be a fairly simple fire effect.
That's right. But before we get into that, we're going to need to spend a little bit of time and talk about distributions.
That's right.
So with that, that is going to wrap this video up. Thanks a lot.